Hello बच्चों, welcome to Sciacademy. Today in this video lecture, we'll be solving the problems based on the quadrilaterals, and it is related to chapter 8, class 9, exercise 8.2. So we will solve the question from 5 to 7. So let's start the lecture. So question 5 is, in a parallelogram ABCD, this is a parallelogram ABCD. E and F are the midpoints of sides AB and CD. So E and F are the midpoints of these sides, this side and this side, respectively, so that the line segment AF and EC trisect the diagonal BD. That means we have to show that this and this all three are equal, and we have to show that the line segment AF and EC trisect this BD. So let's solve the problem. So it is given that ABCD is a parallelogram. E and F are midpoints of sides AB and DC respectively. So now we have to prove that this DP, PQ and QB all are equal. That means this AF and EC trisect this diagonal DB or BD. So for this we have to prove that since E and F are midpoints of AB, this E and AF are midpoints of AB and DC respectively. Therefore, AE is equal to AB by 2. Similarly, CF is equal to DC by 2. Okay. So, this and this are equal, and since E is the midpoint of AB, therefore AE and EB both will be equal to AB by 2. Similarly, since F is the midpoint of DC, so DF and FC are all equal, and therefore DF and DC equals to the DC by 2. This. Okay. So now in a parallelogram ABCD, AB is parallel to DC. This AB is parallel to DC, and AB is equal to DC, because in a parallelogram opposite sides are equal and parallel to each other. Okay, therefore we can say that AE is equal to CF and A is parallel to CF. So this portion A is equal to CF or FC, and also it is parallel to FC, because whole complete side is parallel to each other, and already we have proved that this FC is half of DC and this EB is equal to half of AB. So we can say that A is equal to FC and A is also parallel to FC. This implies that AECF becomes a parallelogram. So we can say that this is a parallelogram, because in a parallelogram two sides should be equal and parallel to each other. So we got that this AEFC is a parallelogram. Now in triangle BAP, this triangle BAP, E is the midpoint of AB. So this is the midpoint, and therefore EQ is parallel to AP, as already we have proved that this is parallel to each other. So since E is midpoint and EQ is parallel to AP, this implies that Q is also the midpoint of PB as per the converse of the midpoint theorem. Therefore, we can say that this EQ is parallel to AP, and since E is the midpoint of AB, and also we have proved that since EQ is parallel to AP, EQ is this Q is also midpoint of PB. Therefore, we can say that PQ is equal to QB. This. Okay. So this is equation number 3. Now, since in triangle DQC, now firstly we took this triangle and we proved that this PQ is equal to QB. Now we'll take this triangle DQC. In this, P is the midpoint of DQ. P is the midpoint of DQ. And FP is parallel to QC. This implies that DP is equal to PQ. So this DP is equal to PQ because of the converse of the midpoint theorem. Since this P is the midpoint and PF is parallel to QC, so and already F is the midpoint of DC, so we proved that DP is equal to PQ. Now this equation becomes 4. Now from equation 3 and 4, we arrived at a conclusion that DP is equal to PQ is equal to QB. Thus, we proved that line segment AF and EC trisect the diagonal BD. Line segment AF and EC trisect the diagonal BD. Hence, we proved the problem. Now, the next problem, question number 6. In this, it states that so that the line segments joining the midpoints of the opposite sides of a quadrilateral bisects each other. So we have to prove that line segment joining the midpoints of the opposite sides. So these are the midpoints of opposite sides, and we have to prove that if we join these midpoints, it will make a quadrilateral. And after making this quadrilateral, if you draw the diagonals EF and GH, then it is asked that so that these diagonals intersect each other and they bisect also, means the section, this section and this section are equal. So we have to prove that this diagonal and this diagonal bisect. So let's solve this. So it is given that ABCD is a quadrilateral, EF and GH are line segments obtained by joining the midpoints of opposite sides. Now we have to prove that EF and GH bisect each other. So we have to prove this. So for that, let us draw this AC, a diagonal of the parallelogram ABCD. Since in triangle ABC, E and G are midpoints of AB and BC respectively, so here E and G are the midpoints of E is the midpoint of AB and G is the midpoint of BC, and we are taking this triangle ABC. So we can show that EG is equal to half of AC and EG is parallel to AC. So this EG will be half of AC because of the midpoint theorem, and EG is parallel to AC. This EG is also parallel to AC. This also because of the midpoint theorem. Now triangle ADC. Now we will take the triangle ADC. This ADC will take this triangle, and since also in this triangle H and F are the midpoint of AD and DC respectively, and then HF is parallel to AC, therefore HF is half of this AC as per the midpoint theorem. So we got that HF is equal to half AC and HF is parallel to AC. Now taking these two equations together, we can have EG is equal to this. This and this gives EG is equal to HF, and EG is parallel to AC and HF is parallel to AC. Therefore, EG is parallel to HF also. Therefore, we got that EG is equal to HF and EG is parallel to HF. So we got that EG is parallel to HF and equal to each other also. So this is a property of parallelogram. So we proved that EGFH is a parallelogram. Now further, EF and GH are diagonals of the parallelogram. This EF and GH. This EF and GH is the diagonal of this parallelogram. Therefore, EF and GH bisect each other since diagonal of a parallelogram bisect each other. Hence we proved this problem. Now let us take the next problem, question number 7. So this problem states that ABC is a triangle, right angle at C, that is angle C is the right angle, a line through the midpoint M of hypotenuse AB. M is a midpoint of this hypotenuse AB and parallel to BC, intersect AC at D. So it is question is that a line through the midpoint M of hypotenuse AB and parallel to BC intersect AC and at D. So this is given. This is a right angle triangle, and it is given that M is the midpoint of this AB and a line segment parallel to BC, this MD is parallel to BC, intersect AC at D. So we have to prove that D is the midpoint of AC. Second question, MD to AC and CM is equal to MA. That means this CM is equal to AM or MA and this equal to half of AB. So let us solve this. So as per the question, it is given that ABC is a right angle triangle and angle C is 90 degree. So this is 90 degree. M is the midpoint of hypotenuse AB and it is also given that this MD is parallel to BC. Now we have to prove that this and this. So for that, let us join this M to C. So now we have M is the midpoint of AB and DM is parallel to BC. Therefore, D is the midpoint of AC as per the converse of midpoint theorem. So, since M is the midpoint of AB and DM is parallel as per the question, so in a triangle, if M is the midpoint and a parallel is drawn to the side of the triangle, then this D will be the midpoint of the third side of the triangle. This is the theorem. So this D becomes the midpoint of AC. Okay. Now, since angle ADM is 90 degree and angle ACB is also 90 degree, therefore, yeah, already ACB is the angle that is 90 degree, and this ADM is the corresponding angle, therefore it becomes the 90 degree. This. Okay. Now summing these two angles, ADM plus CDM equals to 180 degree. This and this. Therefore, CDM is equal to 90 degree because ADM is 90 degree. Therefore, angle CDM equals to 180 minus ADM, that is 90 degree, equals to 90 degree. Okay. Therefore, we prove that this equal to 90 degree, and therefore MD is perpendicular to AC. So this becomes perpendicular to the AC. Now third part, D is the midpoint of AC. This D is the midpoint of AC. We have to prove that CM is equal to MA is equal to half AB. So already we have proved that D is the midpoint of AC. So now in triangle ADM and triangle CDM, this triangle ADM and triangle CDM are congruent. So here DM is the common side of these two triangles, and this angle is already equal to 90, and D is the midpoint, therefore AD is equal to DC. So by the rule of SAS, side angle side rule, we proved that this triangle ADM is congruent to the triangle CDM. Therefore, as per CBSE rule, corresponding parts of the congruent triangles are equal, therefore CM is equal to MA. So we proved that this CM is equal to MA because this already equals and this is common. Also proved that these angles are 90 degree each. So third side, this and this will be equal as per the CPCT. Therefore, we have also M is the midpoint of AB. Already it is given that M is the midpoint of AB. Therefore, M is equal to half AB. So already we proved that CM is equal to MA and that is equal to AB, half AB. Therefore, we proved that CM is equal to MA is equal to half AB. So we solved these three questions, question 5, 6 and 7. I hope that you understood these solutions. If you have any doubts, please ask me in the comment box. Thank you.